Hello, everyone, and welcome to the Soul Forum, the Soul Foundation's monthly digital meeting devoted to the science, politics, philosophy, and culture surrounding unidentified anomalous phenomena, or UAP, formerly known as UFOs. I'm the co-founder and director of research at the Soul Foundation, and I host this monthly meeting so that we can have a serious space for discussion of really the issues of the day surrounding the topic. I'm very excited today to have our a colleague and friend of the Soul Foundation, Dr. Beatriz Villarroel, as our guest. She's an astronomer and the lead scientist on a project called the Vanishing and Appearing Sources During a Century of Observations project. Now, that's a mouthful, but what it means is, as an astronomer, she conducts research on what are called transients, transient astronomical objects, sometimes disappearing stars, that appear in images gathered in astronomical surveys. And she's linked this research very interestingly to UAP in a very ingenious way. I've always found inspiring and interesting. She's trying to correlate these vanishing objects with historical UAP events, and also to simply see if there's a difference between transients that are natural and that might be artificial, possibly. So it's a very ingenious line of research. It's one of the reasons that she has come to work with the Soul Foundation. She's not just a friend of the organization, but she's been on our advisory board since the beginning, and she's spoken at our last two symposia, the first of which was at Stanford. She's also going to speak at our next symposium, which takes place in Italy in October of this year, 2025. So if you're watching this in August, September, or October of this year, 2025, the registration is still open and it's an opportunity to see her in person. But anyway, without further ado, we want to bring Beatriz on. She is a visiting professor at the Nordic Institute of Theoretical Physics at Stockholm University. Again, she's the lead scientist on the VASCO project. And she's recently published in preprints 3 or 4 articles on her research on transients, which show potentially remarkable results. And look, we can have a amazing conversation about this because it's cutting edge research that whatever one thinks of it should be fascinating, and it'll generate even more discussion than it has already. It's making headlines right now, and we think it will continue to. So anyway, Beatriz, welcome, and sorry to give a kind of introduction that could make someone nervous, but as a lot of us think the world of you and your work. Thanks. So to kick things off, I want to ask you, how you got into this line of inquiry in astronomy. It's very unusual. It's very innovative to want to link the potential of UAP or objects that would create technosignatures to the study of transients, and also to look back at very old astronomical data. I think most astronomers don't do that. So how'd you get into this?
So it's actually a long story. So I was a PhD student, and I was writing short stories or fables, and I was writing this story about a quasar. Well, I will not dig into the details.
No, tell us. You were saying you were writing fiction or science fiction.
I was enjoying that kind of stuff when I was a student or PhD student, and then when I finished it and I killed off my poor quasar, and unintentionally, but it happened to the poor quasar, and I just wondered, can an object just vanish? Can a star vanish? Has anyone ever looked for vanishing objects? And it was just from a fable to just this idea. And then first 1 year passed and I didn't know how to check that. 2 years passed, I didn't know how to check that. And on the 4th year of my PhD studies, I finally learned about the US Naval Observatory Catalog, USNO catalog. And that is from the 50s. And I said, oh my God, this is my opportunity to check if any object or any galaxy ever vanished. So it was just a crazy thing. that I was like curious about and I wanted to check. And then I learned about the concept of failed supernova, that some stars could collapse directly into black holes without emitting a bright supernovae. And I was just excited. Okay, let's go and look for this. So we did a pilot study. So me with 2 bachelor students, we tried to look for it. We found some kind of candidate, and it wasn't fantastic. Other people thought also, oh, this could be Dyson spheres if you find things that vanish. So there was a connection both to like just the fundamental idea, can something just vanish? And failed supernova, but also these technosignatures research. It was I mean, there is a cross section between different fields of astronomy. So it was a fun thing. And then I met senior scientists who said, okay, let's do it in a real way. Let's actually do it like with the whole sample. And I kind of thought it was cool. And in 2017, 2018, we started thinking about how do we do this with a complete sample. And we started, working with cross-matching, again, the US Naval Observatory catalog to the Pan-STARRS, to the SDSS. And then we came to a moment where I had 150,000 candidates from the US Naval Observatory catalog that couldn't be found in the modern ones. And this was diluted down to like 15% of the sample because it's too big to handle. So we took 15%, and that means 24,000 candidates that I had to look through one by one. Yes, I looked through alone 24,000 candidates, like small image cutouts. And among these, we found 100 transients. And these 100 transients appeared and vanished within one plate exposures. You see one star in the 50s that you cannot find again. And we published a paper on this. We didn't know what it was. We were wondering, like, what something short-lived, what could that be? And then after we had published this study, I decided to do a follow-up analysis. And I discovered that on one of these images, I had 9 of them. Not 1, 9 things that appeared and vanished. And I was like, oh, what is this? And of course, you try to analyze, you try to understand it in the best way possible. And we there arrived at 2 possible explanations. Maybe some kind of weird contamination of the plates that all, for whatever reason, produce star-like objects that all have star-like brightness profiles, because we also did diagnostics. We measured the star, the brightness profiles of the stars. Or it is maybe some kind of reflections in space from something artificial. However, these images were from before Sputnik 1. So then the next paper, our 2022 paper, is a suggestion on how to separate between these 2 cases, where you not only look for multiple objects, but you also look for those that are aligned in order to search for the best possible candidates to be actually an artifact of something non-human that is in space. So it's just like one question led to the other.
That's really quite a evolution. You know, it started with fiction or science fiction, and it really was just you started with a very kind of basic and innocent question about whether an object could vanish, and you made it to this strange possible discovery of seeing 9 transients where you thought you would see 0 or 1. But recently, in updating that work, you were challenged by a peer reviewer to we'll go into that in a second, but a peer reviewer challenged you in a certain way that led you to discover something much more. And right now, your data is suggesting that you've got thousands of such
or hundreds of thousands,
hundreds of thousands, a really remarkably high number of transients appearing in what's called the in plates from, I think it's called the Palomar Observatory Sky Survey from the 1950s. And so these are, again, pre-Sputnik era plates, which show that there may be something in orbit of the Earth at that time. And you've got a remarkably high sigma on the results, much
Yeah.
higher than high confidence data would be. So tell us how you know what you're seeing in this data,
So
and yeah.
so this was like so we had already found some candidates where we looked back at this test that I mentioned where we were looking for aligned things, like alignments or things that are in a narrow band, because you could have, I mean, something could be in a narrow band or alignments either because it's kind of tumbling in space, let's say when it's in orbit, and then sometimes you'll have glints, or like solar reflections, or it could be that you have something that is in a formation. So we were looking for these things, and the paper is focusing, however, on the solar reflection hypothesis more. And so then the referee said, okay, but you really need to prove that it is solar reflections. So if that's true, then you're going to have other physics, or that they vanish in the Earth's shadow. Because of course, if something is in the Earth's shadow, you're not going to get solar reflections there. And if you had glints due to solar reflections, you're not going to have them there. So you can expect a deficit. So, and I was thinking, how do I do this? Because now our best candidate, actually from the alignment test, is a candidate that has a quite unusual alignment. You see 5 objects in a narrow band, and the probability for that, for that alignment, is something like 1 in 10,000. And for a weird coincidence, it happened on the Washington DC flap in 1952, 27th of July. And
Just so people understand what you
yeah,
mean these were events in 1952, July of 1952, where over 2 weekends there were many UAP sightings, both at the taking place
yeah.
at the Washington National Airport. There were military observations at the time, and it really
Mm.
created quite a controversy where the Air Force had to address it.
Exactly. And for whatever reason, our best candidates were from those dates. And actually 2 different sets, but one is an alignment, another is a triple transient that was discovered in a high confidence data set, very carefully selected by my colleague Enrique Solano. So one starts wondering, like, oh my God, is there a coincidence or is there a correlation? Anyway, so so I was thinking, like, how do we test this with the Umbra when we just have a handful of candidates? Because I was always thinking of our candidates like just a handful of them. But then I thought, okay, so let me use actually this entire data set Enrique sent me. And we have 106,000 like transients there. Many of them we think are just probably plate defects that are like, this sample hasn't been visually inspected, so many of them might be just false positives, and some of them we believe might be real. Of course, we want to find the real ones, so that's why we're looking for these alignments. Anyway, so we run this test and try to check how many of them are in the Earth's shadow. And we find a remarkable deficit when you just, if you just take the raw data, not raw data, the raw tests, and you look how many are in the shadow and how many you expect in the shadow, you land at an under density that is significant at the 22 sigma level. And that's something, I mean, it's a bigger chance that you get eaten by a black hole tomorrow than that you land on that value by chance. You can also do it much more refined by comparing which plates were actually exposed and at what time. And you look at the same transients, and you still arrive at an almost 8 sigma result, which again is extremely low probability to happen by chance. And then you start like really wondering, like, oh my God. So the deficiency we see is like 1/3 of the sample seems to be missing in the Earth's shadow. And that's a big number. That's
Yeah,
a big number.
it's a remarkable number, and so is the probability of you know your provisional conclusions about this being correct. I want to ask
Yeah.
one question. It's a very naive question, but I
Yeah.
think it will be helpful not just to me but to many people watching this.
Yeah.
Explain the significance of the fact that many of these possible transients disappear when they enter into the Earth's umbra or shadow.
So these transients that we see, that are like point sources. They are, let's say, if you would have an asteroid, or I mean, the way how we are looking at these point sources, if you would have an asteroid or something like that, if it would be vanishing, I mean, if something is vanishing between two plates in half an hour, it's going to usually leave a streak. If you would have asteroids, it would be streaks. The only thing that we know today that are having the kind of signatures that we see on the sky today are high orbit satellites and space debris, because they are very flat, they are highly reflective. Imagine a mirror or something really flat in a high orbit. Sometimes these things produce these kind of short flashes of light for, let's say, half a second. And then you see something that looks like a point source. And if it would be at much lower orbit, you're more likely to see the streaking things. And so that's the significance. So it kind of indicates that we are looking at something, at many objects that are flat and very shiny.
Okay,
And don't look very natural.
which of course is someone interested in UAP. That's a very interesting hypothesis or inference, because reported UAP are often fairly flat or disc-like, and in fact they're metal and reflective, even in sunlight in the atmosphere. Okay, so my next question, Beatriz, is and again it's another naive question, but it'll just help me and people listening understand better the research. Explain to us what a aligned transient is, or aligned transients are.
Well, sometimes when you have a satellite or space debris, now of course depends on the way how you're imaging your stuff and the telescopes and setup, but sometimes you can see an object, well, as it orbits, it's going to be rotating and tumbling, and you get flashes that are on a line or along an arc. And also, of course, if you have something in formation, you might also see something that looks like it's in a formation. So these things are they're good signatures and that one can look for. So if you want to test the hypothesis of that you have an alien artifact, and you think that, okay, I don't know how to separate all these transients I have on the plate from, how do I separate between contamination and real reflections, then you can go and look for things that are on a line, for example. And that's what we try to do. We try to look for things that are on a line or in a narrow band, for the possibility of formations as well.
Okay, got you. Okay, amazing. Again, this stuff is super intriguing. In a moment we're gonna bring in a special guest, so to speak, to ask some follow-up questions. But I've got one more, which I think is important for people to hear and to understand. Now, you've drawn multiple interesting correlations. Kind of, there's a triangle of correlations here between, if I understand it, the transients first. Second, above ground nuclear tests taking place, often, I think, very close in time to the appearance of the transients. And then you're also correlating both the transients and the nuclear tests with UAP events. So tell us about that. That's pretty remarkable to me, that you don't just have correlation between two things. You've got correlation between three things, and in all directions.
So the genius behind this work is my colleague Stephen Brewell, who is the first author of the paper. He's at Vanderbilt University. So he has taken samples of nuclear tests, and he has taken the VASCO samples, the same that the one that Enrique sent to me, and he has taken the samples of UFO sightings from the UFO catalog. And he asked the question, he was thinking back on the same interesting coincidences that we saw when our best cases happened to be during the Washington 1952 flap. And he asked, could it be so that there is a temporal correlation that explains these coincidences? And of course, if you also have a temporal correlation, it's not going to agree with the notion of that the entire sample are plate defects, because then you wouldn't see those correlations. If it's enough with that you have a significant fraction, and you would already have interesting correlation, perhaps with with something as nuclear bomb tests, if there is a physical connection. Although remember, of course, always that correlation does not equal to causation. However, it does not agree with plate defects. This is something that you can say that this defies that. Again, the same way as with the Umbra test also defies the plate defect hypothesis. And so he tested this, and he found weak correlations, but significant correlations. And then you see these correlations between, this is around 3 sigma level. I don't remember exactly, 2.8 or something, but it's around 3 sigma for the UFOs and nuclear bomb tests. And this is, of course, agreeing with the lore and the legend of UFOs and nukes. And he sees the same thing with the transients and the UFOs, and the transients and the nukes. So it's like a triangle of things. So that was very nice and very fun to see. I found it
Yeah,
super exciting.
it's remarkable, and we have to remember that, you know, even if we treat it just as data, it's something people can follow up on, and it opens up scientific research. Now that brings me to, I think, an interesting turn in this conversation, which is we're going to be joined now by my co-founder at Seoul and Seoul's chairman of the board, Stanford University medical school professor, entrepreneur, inventor, cancer researcher, the remarkable Garry Nolan. And this is going to be fun because, I mean, look, as you both know, and as many people listening know, you know, even 10 years ago, but certainly 20 years ago, it was unthinkable that we would have scientists of your caliber not just discussing UAP in public, but actually doing scientific research according to norms and with proper funding into the phenomena. And you both do that. And you both are remarkably imaginative scientists, extremely rigorous scientists. So we want to give the audience an opportunity to hear the two of you in dialogue about this research, and for you, Garry, to ask some more questions of Beatriz about the data, how she gathered it, how she analyzed it.
Well, first, I want to ping off of something that you just said a moment ago about doing science properly. And so first, I want to congratulate Beatriz on this remarkable series of papers that she's done. And frankly, I think, very careful way that you presented it by trying to stay away from hyperbolic claims. I mean, there's nothing wrong with saying, hey, there's an association with UAP. Of course, you're going to be quoted as saying in the newspapers that these were UAP, but I note in the language that you used, you were incredibly diplomatic and careful about it. But I want to also point out something that's been happening now for like the last 2 or 3 years, whether it was the paper I published on the Council Bluffs material with Jacques and Larry Lemke, or whether it was Kevin Newth's papers, or whether it was papers, in fact, frankly, from Robert Powell and others, and now you and Avi Loeb, that those papers are not being criticized by the usual chorus of critics. And I think that's, first of all, for 2 reasons. Because scientifically, such as with your work, it was done correctly. You make careful note of all the methodologies that were used, come up with alternative explanations, self-critique yourself, go to peer review, etc. And so in essence, almost what it does in a good way is make the paper boring. And so, not in a negative sense, but so boring that they can't be critiqued, because the hyperbolic claims don't become a magnet for the trolls. And what it does is it places it squarely in the realm of being able to be looked at by other scientists And what I hope that we're doing with the Soul Foundation is creating an area within which people can have a mature conversation. And so what I'd like to know first is from the, let's say, I'm sure there's critics out there already in the astrophysics field who are already ringing the bell. Besides those who are doing that, is there so far any positive feedback that you're getting about where people are at least saying, hey, this is interesting? Tell me
I
more.
have received, yes, this is interesting from some people, some astronomers, that they're getting curious about it. And I think that already makes me like happy, because I don't think you can, I think people need to see that this work stands the test of time before they before they accept it. So, and I think people are going to want to redo things. So I hope we can make our samples public soon when the papers are published, so that everyone can go into it. And I'm almost even imagine if you would have a website where you kind of jokingly put the title, "Look for your flying saucers yourself." And they can do all these tests with the raw data. They can look at the images. They can look at, like, do diagnostics, because just looking at the images with your eyes is going to fool you, because the eyes cannot, very often you need diagnostics to tell the difference between a star and a round plate defect or something like that. But imagine a page that does all these diagnostics for you, and then it goes in, it does the alignments test, it does the Umbra test, and then, like a little bit like a game, you can either arrive at the flying saucers or not. So I'm a little bit playing with that idea. It would be kind of a fun thing to do.
So that kind of leads to a question of, I mean, this data presumably is already available. I mean, you got a hold of it. Where is it kept, or behind what permissions is it kept that you had to overcome to be able to do the analysis that you did?
Everyone have access to the images. You can get the raw images from the STSCI survey, and there's a lot of images there that you can get. But then if you want to get, let's say, if you want to have a list of transients, the Spanish Virtual Observatory has already posted some of the transient catalogs. The latest that is a little bit cleaner than the others, we still haven't published, and we have to do it together with the papers. And so you have, of course, these raw images, and from these raw images you have to create a list of transients. And there are different ways of doing this, but you're going to have to compare images of different epochs. And of course, it's not enough to only compare 2 images, because then you're going to get, after every asteroid, especially if you have 50 years of difference, you're also going to have different plate depths. So there's a lot of analysis going into selecting these transients. It's not as too easy, because you also need to look at every dot and try to make diagnostics. Is this a star, or is it a round thing, or what is that? And Enrique Solano has produced a beautiful catalog then, where he has been cleaning up this data and done a lot of work with that.
So a lot of the data then, from what I'm understanding, is collected but still offline, waiting to be processed from raw data into usable data.
Some is online. Some of these steps there, you can find them because they've been published with the MNRAS and are at the Spanish Virtual Observatory webpage.
Got it.
And but in the latest preprints, we have a slightly cleaner sample, and that one we still need to make available. And I hope we can do it with once the preprints are published.
So define clean in a way that hopefully convinces people that it doesn't sound like doctored.
And what does doctored mean?
Fixed,
English
hoaxed, played with.
So if you have a star, let's say it's going to have a PSF shape, point spread function, and you usually want to match your object to this point spread function. And you also have photographic plates that are slightly different than CCDs. So their response and the way how they build the luminosity of the objects is not the same as on CCDs. So what you need to do is to basically make sure that the objects, the points you have, are matching this PSF, that it has this point spread function. And that's how you select your stars. You have the morphology, you have these PSFs, and you need to just get rid of all the crap that you have.
Could you define, for maybe you already did, what a point spread function basically is?
So it's basically a Gaussian. You just look there.
Right.
And,
so a dark spot in the middle with a fuzziness going out to the edge.
Exactly.
Yeah.
So that's what you do. You match against this Gaussian, and that's.
So I noticed in one of the papers that you mentioned that you're starting down the path of using AI to either look for or validate or create classifiers.
Exactly. We need to somehow be able to clean away plate defects, more of them. Some of them are assembling on the edges of the plates, and you need to, how do you really get rid of all of this? And I don't know how to do right now. So we're talking with Stephen, we're talking to our AI expert friend. We need to somehow just improve the samples. And I don't know yet how you do that in a way that doesn't skew the data or bias the data. So
one of the things that I was wondering about in terms of the correlations to the nuclear test sites and dates is how many dates might not have ever actually been recorded because, for instance, maybe they were Soviet tests versus Chinese tests.
That's a good question. I think we are missing out on quite some there.
Yeah,
possibly.
But you might be able to increase the values.
Here's. Would you mind if I jump in with
Please, go ahead.
Question for both of you. Now, something we haven't brought up yet, Beatriz, is that I believe there's a date in 1956 when the transients disappear. And that's a date that comes before the end of this particular astronomical survey. So tell us a little bit about this, and then after that, Garry, I'd like to hear your reaction to that, because I think this is also a very significant feature of the data.
So they were reporting that the UFOs vanished after a certain date, and one stopped seeing them appearing around nuclear facilities. And I think we also don't see the correlation after 56. So it was one of the things that was noted in the paper by Stephen. So I don't know, maybe it's a coincidence. Maybe we have too little data, but it's nevertheless interesting.
So what kind of, let's say, atmospheric, now I know that doesn't explain why things showed up before as opposed to after, but what kind of atmospheric effects might have been created that anybody could imagine by nuclear tests themselves that would mimic any of this? I mean, the reflectivity as an example.
Let's say if you have, we were talking about it might be some kind of glowing fireballs or so in the atmosphere. However, they are going to be streaking if a telescope is tracking the stars, and they are going to be seen as streaks, not as point sources.
Yeah, I'm asking these questions more to provide ammunition for the people who are, first of all, going to ask those questions, perhaps sometimes reasonably and perhaps sometimes just to be annoying, so that the audience, so armed, could have your answer as the immediate comeback.
Yeah, now, it's the same thing with cosmic rays. People sometimes say, okay, so maybe it's not plate defects, but maybe you have cosmic rays, because then that could explain why you see a correlation with the nuclear tests. And why let's say the transients are just some kind of cosmic rays or that got stuck on the plate. And of course, if you also have nuclear tests, you'll have more of it around those dates. And of course, then I wonder, why would we see a correlation with UFO events? And I also would wonder, why does it vanish in the umbra? Why does it vanish in the Earth shadow?
Right.
So I think that's where.
Wouldn't you expect in the umbral shadow, is that redundant? Would the moon be capable of creating
much weaker ones? Much weaker ones.
Not much weaker ones. And what about, is there any way from these plates to pick up polarization of the light? Because reflection would often lead to polarization of the light, right?
I haven't thought of that, but that's a great question. So would need to think more about it. I don't think, yeah.
Is there?
I have to think.
Yeah, I got to think about. I wonder if there's anything in the photographic plates that would allow you. I mean, the photographic plates are they behind glass? And would the glass lead to? Are any of the lenses polarized?
I don't think so.
Already, yeah.
Well, and one thing here is I noticed in one of the papers or one of your interviews, Beatriz, you noted that when the plates, when there are differences in, I believe, the depth of the plate, that can create.
Yeah, it creates. That's one of the reasons why we might need to use AI. Sometimes you use an automated method and you get something. It tells you, oh, you got lots of transients on a plate, and then you go in and watch, and it's actually just a little difference in depth between two images. So one goes deeper than the other, and then you collect a lot of transients, but they are not transients. They are just an error. I mean, difference in how deep the image is. Or you get a lot of transients sometimes because the astrometry isn't perfect. So you're comparing slightly their offsets in the coordinates. So there's all these things that sometimes have to be sorted out and that are diluting the sample.
So
it's
what kind of resources, meaning money, are required now to go back over the data in an automated fashion, but also to, let's say, speed up the cleaning up of the original data and all of the stuff that you're talking about? I mean,
so Enrique has already done a very beautiful, like, automated fashion of all these, like, of the photographic plates, but I guess we would need the AI to help with all these little things, like the differences in depth, removing scanning defects, also more efficiently.
So if you had all the needed resources to, at the very least, replicate either the VASCO or the Palomar results, what would those resources be? I mean, how many postdoc equivalents are required? What kinds of computational resources are needed? How much of that, for instance, could be, donated by people as time, as volunteers versus people you would want on staff?
Gary's asking you, I think, for your dream setup as a scientist. If you had the dream budget, the dream staff, the dream facility, dream resources.
Okay, then I would have two postdocs. No, one postdoc and a PhD student. And we would have access to the Vatican. We would also have access to the virtual observatory of Ukraine. And we would redo the same experiment, or replicate it with these different surveys. And we would go and see, do we see transients? How many transients do we see? Well, the number is not interesting for diagnostics, but what we would really want to see is if there are aligned transients, if there are groups of transients, and most important, do they vanish in the shadow? Do they correlate with nuclear tests? We will simply redo all these things, all these diagnostics, but with different samples from different observatories. That's what I would like to do. And maybe one postdoc and a PhD student would be enough.
Do any of them look like they're geostationary?
I don't know. I think not really. I think they're more on the geosynchronous ones.
They just show up and then they're
vanished.
Gone.
Yeah.
How many observatories have these kinds of plates?
There are quite a lot. Cave du Ciel has a complete chain of different observatories that one can, that one can go to their site. You can't go to their site, but you can probably contact them and you can get access to the original plates. But the original plates is not going to be enough because there's a big process in digitizing them.
Yeah. So
you preferably go to a place that has digitized all the plates.
Right.
But it could be even more interesting if it wouldn't even be us replicating it, because I think there is one thing if we replicate it, but let's say if governments would give a little amount of funding to the observatories there that have these plate collections. I think it's enough with 300,000 euros.
Okay.
If each government gives it to their, let's say, if the German government gives it to Sonneberg Observatory and says, okay, digitize all these plates, extract the transients, and take a look if you see this difference or this deficit in the umbra.
Mm-hmm.
Because if you would do that and replicate it from different observatories from different countries, you would learn so much more about this effect if you can confirm it. And also you would have you would have much more information about the distribution of these objects, what they are. It would be a much more interesting project than if we just replicated with Palomar once more.
Right.
Or with Harvard plates or something. You
Right.
would need more of systematic effort going into this in the replication effort.
So is any of this... Go ahead, Peter.
I was going to say, we have to go to the break soon. So I want to ask you guys both a question about what I understand the sigma to be on this. I mean, I know, Beatriz, you've told me that finding that you've got, I think, 22 sigma on some of the results is it's very intimidating to see that about your own research. So I want to ask first a question to Garry about that. Give for the general public a sense of what that would mean if that's accurate or if that holds up over time, and what could be done to kind of further validate that that's accurate.
Well, I mean, 22 sigma is an extraordinary number, first of all, in terms of confidence interval. I don't know what it directly translates into what we usually use as a p-value in biology of confidence. But, as a friend of mine, as we both know, we all know Jacques Vallée, he says 95% assuredness is enough for a scientist to produce a paper. But 95% assuredness in the intelligence community assumes that information has been given to you, and you really want the other 5% because that's where the real value is. So I think, if we could give a sense to the lay community what a 22% sigma means, I mean, it essentially means you're going to win at roulette several times in a row at Las Vegas, where you placed it on a single number. Right?
Okay, well said.
I mean, I'll let a statistician give the direct number, but Beatriz, give a layman's term metaphor.
Well, I usually think of that it's a bigger chance that one gets eaten by a black hole tomorrow.
Yeah. That was a good one. I heard it earlier.
Yeah. Or that I win in lottery.
So we have to go to our break now with Marek von Rennenkampf and the Soul Briefing. So we'll be back soon.
Hello and welcome to the August 2025 edition of the Soul Briefing. I'm Marek von Rennenkampf. This month we'll be covering new details on the brazen incursions by unknown objects over Wright-Patterson Air Force Base late last year, eyebrow-raising UAP-focused comments from Vice President J.D. Vance and Senator Mike Rounds, and the introduction of the historic UAP Disclosure Act by Senate Democratic leader Chuck Schumer. But we begin this month's briefing with the groundbreaking work of astronomer Dr. Beatriz Villarroel and her colleagues. In a fascinating new paper titled Aligned Multiple-Transient Events in the First Palomar Sky Survey, Dr. Villarroel and her co-authors analyzed thousands of transients, star-like phenomena that appear in pre-Sputnik astronomical surveys of the sky when no man-made objects orbited the Earth. Now, the key to the astronomers' work is that they find with exceptionally high confidence, far higher than the 5 sigma standard, generally considered to be the threshold for claiming a statistically significant discovery in astronomy or physics, that these transient phenomena are not found in the Earth's shadow, which is also known as the umbra. This intriguing result, if it is confirmed in the peer review process, is important for 2 main reasons. First, it largely rules out optical artifacts or defects as explanations for the transients. Imaging defects, for example, would have no reason to avoid the Earth's shadow. Second, the dearth of transients in the Earth's shadow suggests the presence of previously unknown sunlight reflecting objects that, due to the optical characteristics of the equipment involved, were several hundred kilometers above the Earth. Not only that, Dr. Villarroel and her colleagues found several candidate transients that appear aligned. If the transient phenomena are indeed reflections of the sun off of bright, shiny objects in the pre-Sputnik era, such alignments suggest any number of possibilities, to include multiple objects reflecting the sun as they fly in formation, different parts of the same object reflecting the sun, erratic flight dynamics, or a combination of these possibilities. Intriguingly, one of the most statistically significant alignments of transients was captured on July 27th, 1952, which coincides with the second weekend of the well-known and very well-documented July 1952 UAP incidents over Washington, D.C., when multiple radar facilities, pilots, and ground observers all saw objects behaving in perplexing ways over the course of 2 successive weekends. Now, this work by Dr. Villarroel and her colleagues is particularly interesting because the earliest U.S. government analyses of UAP, dating back to the late 1940s and early 1950s, all describe, quote, metallic or, quote, light-reflecting objects. Not only that, the UAP era formally began in late June 1947 when a pilot named Kenneth Arnold observed a, quote, bright flash reflecting off of one of 9 disc-like objects that flew erratically in the vicinity of Mount Rainier in Washington state. Arnold's hand-drawn image of one of the objects specifically states, quote, very bright when sun reflected, end quote. Now, the September 1947 Twining Memo, one of the most important documents in UAP history, which ordered the U.S. Air Force's formal investigation of the phenomenon, described the objects observed by many credible witnesses up to that point, first and foremost, as having a, quote, metallic or light reflecting surface, end quote. Similarly, a late 1948 Air Force analysis of UAP largely rules out mass hysteria, individuals seeking media attention, or media influence as explanations for UAP because, in one notable example, 2 trained observers working with the then U.S. Weather Bureau saw, quote, metallic discs, end quote, with a, quote, flat bottom, end quote, on multiple occasions months before Kenneth Arnold's widely reported June 1947 sighting. Now, while time constraints do not permit a full accounting of the many, many incidents where credible witnesses reported, quote, flashes, or in another notable instance, the, quote, bright, shiny appearance of sunlight reflecting from aluminum, end quote, suffice it to say that the UAP reported beginning in the late 1940s offer a plausible hypothesis for the brief, transient glints identified by Dr. Villarroel and her colleagues in those contemporaneous astronomical surveys. It should also be noted that many witnesses described such metallic, light-reflecting objects exhibiting bizarre, erratic flight characteristics, such as, quote, wobbling, oscillating, and flipping. Such observations are also not merely relics of the past. The Navy aircrew that observed the well-known gimbal UAP in 2015, which appears to have a disc-like shape in infrared video, reported that the object appeared to engage in a, quote, wobbly motion after the end of the publicly available video segment. Such erratic flight characteristics and movements from objects with highly reflective metallic surfaces could conceivably account for the frequent aligned flashes observed by Dr. Villarroel and her colleagues. Now, finally, it should be noted that Dr. Villarroel has submitted another intriguing paper which finds statistical significance among transient observations, nuclear tests, and large-scale historical UAP sightings. That paper, along with a third paper recently published in the Royal Astronomical Society's journal, and which previews the astronomers' innovative Earth shadow analysis method, is linked in the description below. Now, it would be quite the understatement to say that this area of research deserves close attention. And on that note, I am pleased to announce that Dr. Villarroel will be the guest on this month's Sol Forum, the Sol Foundation's long-form discussion series, alongside Drs. Peter Skafish and Garry Nolan. Sol Foundation members enjoy early access to the discussion and may take part in the live Zoom breakout session immediately afterward, this Friday at 3:30 p.m. Eastern Time. To join the Sol Foundation and this exciting conversation, please look for the link in the description below or visit thesolfoundation.org and click Membership. Newly released FAA documents, courtesy of John Greenwald and theblackvault.com, provide intriguing details about the incursions of unknown objects over Wright-Patterson Air Force Base in Ohio last December. Now, just as a reminder, these flyovers were so brazen that they caused the facility to shut down its airspace, which drew national media coverage. The newly released FAA documents note that the base's control tower tracked up to 17 of these unidentified objects on radar in the vicinity of Wright-Patterson, and that base security forces reported the objects, quote, turning lights off and flying past them in close proximity. Now, as loyal Sol Briefing viewers may remember, the incidents over Wright-Patterson were just one in a series of brazen incursions over sensitive military facilities and assets in recent years. Perhaps the most notable incidents occurred in late 2023, when a dozen or more objects flew with complete impunity over Langley Air Force Base in Virginia for nearly 3 weeks. Now, Langley, it should be noted, is a critical air defense facility that houses the F-22, one of the Air Force's most advanced fighter aircraft. In another incident uncovered through superb Freedom of Information Act work by researcher Dustin Slaughter of the UAP Register, government contractors and drone specialists at the Avon Park bombing range in Florida observed a, quote, metallic, end quote, cylindrical object, and that, in yet another nod to Dr. Villarroel's groundbreaking research, quote, the sun was reflecting brightly on its left side, end quote. In fact, the primary witness first noticed the object because of, quote, a bright reflection in the sky that caught my attention, end quote. Now, according to the main witness, one of 3 to observe the UAP, the object, quote, then disappeared in front of our eyes, end quote. Now, from an analytic perspective, the fact that incursions of unknown objects have occurred at Wright-Patterson and Langley Air Force bases, along with the incident at the Air Force's Avon range, is intriguing. Beginning in the late 1970s, noted UAP researcher Leonard Stringfield began documenting allegations from ostensibly credible military and government officials describing retrieved UAP and associated research efforts. One of Stringfield's many sources, a former intelligence official whom he met through his son-in-law, alleged that retrieved craft and, quote, secret UFO research operations, end quote, occurred at Wright-Patterson and Langley Air Force bases, as well as the Avon Range. Now, of the hundreds and hundreds of military bases and sites in the United States alone, the correlation between long-standing allegations of secret UAP research activities at specific facilities and some of the most brazen incursions by unknown objects in recent years over those same locations is certainly intriguing, to say the least. Now, it should be noted that Stringfield received high praise from Captain Edward Ruppelt, the first director of Project Blue Book, 2 decades earlier in Ruppelt's 1956 book, The Report on Unidentified Flying Objects. Now, that book, which details countless perplexing UAP incidents, is a must-read for any student or analyst of the UAP topic. In an August 1st podcast discussion, Vice President J.D. Vance stated that he is, quote, obsessed with the UAP topic and with recently released UAP videos in particular. Vance is just the latest Trump administration official to make intriguing comments on the topic, following statements from Secretary of State and Acting National Security Advisor Marco Rubio, who spoke out several years ago in his capacity as the Vice Chairman of the Senate Intelligence Committee. But we've also heard from Central Intelligence Agency Director John Radcliffe, former National Security Advisor and the current nominee to be the U.S. Ambassador to the United Nations, Mike Waltz, and from Trump himself, who has described conversations with Air Force pilots who observed round, spherical objects that outperformed their fighter jets. At the same time, Congresswoman Anna Paulina Luna of Florida told congressional reporter Matt Laszlo earlier this year that Director of National Intelligence Tulsi Gabbard has been, quote, extremely helpful, end quote, in Congress's ongoing investigation of the UAP topic. Now, speaking of congressional investigations, Senator Mike Rounds of South Dakota, a key player in the Senate on the UAP topic, stated in a July 29th interview that credible government and contractor whistleblowers have described objects that exhibit extraordinary technologies and apparently are capable of extreme performance. This, according to Senator Rounds, includes transmedium travel, which is the ability to seamlessly transition between air and space or air and water. Senator Rounds also described objects capable of achieving extreme speeds and climbing to high altitudes in very short amounts of time. Describing the whistleblowers that have spoken to the Senate behind closed doors, Rounds said, quote, there is no reason for them to come in and try to tell us stories. These are folks that are very, very capable. They are brilliant individuals. They fear sometimes that if their whole story got out, they'd lose their jobs, end quote. Now, Rounds' statements echo comments from former Senate Intelligence Committee Vice Chairman Marco Rubio, who stated that UAP whistleblowers fear reprisals, both professional and to their lives. Now, Rounds, who, like Senator Kirsten Gillibrand of New York, another key congressional figure on the UAP topic, sits on both the Senate Intelligence and Armed Services Committees, which, in theory at least, should be informed of all advanced technologies under development by the United States. But, as Rounds states in this most recent interview, even after vetting, some of the objects and technologies reported by whistleblowers remain truly perplexing. Rounds, importantly, is a key co-sponsor of the UAP Disclosure Act, which, as Soul Briefing viewers will remember, is one of the most extraordinary pieces of legislation ever introduced in Congress. And on that note, on July 29th, Senate Democratic leader Chuck Schumer formally reintroduced the UAP Disclosure Act as an amendment to the 2026 National Defense Authorization Act, which is considered must-pass legislation each year. Senator Rounds, Senator Gillibrand, and Senator Todd Young of Indiana, a member of the Senate Intelligence Committee, all joined Schumer once again in co-sponsoring the legislation. Now, as a brief refresher, the Unidentified Anomalous Phenomena Disclosure Act suggests that a secret government, quote, legacy program has retrieved and is attempting to reverse engineer UFOs and, quote, technologies of unknown origin. The eyebrow-raising term non-human intelligence is formally defined and mentioned over 24 times in the Disclosure Act, which would also establish a review panel of 9 distinguished experts in various fields to review classified government UAP records for ultimate public disclosure. This is now the 3rd time that Schumer and Rounds have introduced the Disclosure Act. While the House previously stripped the most critical provisions from the legislation, Congressman Eric Burleson of Missouri has vowed to introduce companion legislation in the House. Burleson has also expressed some optimism that the legislation will pass this year, given that Mike Turner of Ohio, the former chairman of the House Intelligence Committee, whose congressional district, oddly enough, includes Wright-Patterson Air Force Base, and who was widely believed to have blocked the Disclosure Act previously, is no longer in a position of significant authority. At the same time, according to Congressman Burleson, the current chairman of the House Intelligence Committee, Rick Crawford of Arkansas, quote, seems open to help, end quote. Schumer, in a fantastic July 30th scoop by ace congressional reporter Matt Laszlo, also suggested that Turner was a key obstacle to the passage of the Disclosure Act in previous years, and that his removal may indeed improve the legislation's chances of passage. Asked by congressional reporter Matt Laszlo about the intent and importance of the UAP Disclosure Act, Schumer, in a rare unscripted comment, responded, quote, gotta let people know the truth, whatever it is, end quote.
Okay, welcome back, everyone. We're continuing our interview with Dr. Beatriz Villarroel, and Souls and Stanford's Garry Nolan is with us to really, at this point now, to have a discussion about the significance of this, not just the results, but this kind of project for science. Both of you undertake research that, to most scientists is extremely controversial because it concerns UAP, or at least the possibility of artifacts not made by human beings. Garry does that in the context of material science currently. And Beatriz, we've been discussing your work. So I have a question for both of you, which, as a non-scientist, as a social scientist or humanist, is raised for me every time I think about your work, both of your work, is, how does this get you, this kind of research get you to the heart of what science is? Because we forget that at the times before paradigm shifts and breakthroughs, people think scientists are absolutely crazy for pursuing new hypotheses, new ideas, heretical innovations.
Go ahead, Beatrice, if you'd like first.
Well, I'm just a very curious person. I just want to have answers to the things that I'm wondering about. So I guess there's something, well, what can we call it? A little bit of a hedonist approach I have in science, that I just do what is fun. I enjoy exploring certain ideas, certain directions. I move where my curiosity goes, and it led me in this direction. It led me into trying to understand whether they are UFOs and what they are, if they are physical objects like flying saucers or not. And that's all I can say for my own sake. It's just a discovery and exploration in data for me.
So I take it from a couple of different angles. First, kind of the before and after. The before is, when I published the Council Bluffs paper, which I think is frankly a minor paper in terms of whatever it is that we attempted to conclude, and how careful we were in the language, as opposed to the kind of biology language that I write about in my cancer biology and immunology papers, where even though I'm just as careful in what I say, I'm more confident in putting forward ideas because I know that they're going to be accepted by the community much more readily. And so I think we're further than we were 4 years ago when I published the other paper, but still not in this confidence realm where we can put forward speculation that won't be immediately attacked. There's skeptical attack versus, just outright, malevolent attack. But I think, again, the good thing about how science is done, and I push this idea constantly, don't put a conclusion or even the data out there until you've at the very least filtered it, or make sure that you found all of the negative inputs or problems that could be there, because you don't want Twitter to find the obvious problem for you. And so I again applaud what Beatriz did, and that even though she's only been talking about the transients, I think over the last year off and on, I had no sense of the amount of effort that had gone on behind the scenes already to produce the papers up to the level of where they are. And so that speaks to how science is supposed to be done. And I'm sorry to say, it's not how the Nazca mummies should have been done. It's not how the Boogosphere has been done. And so I just hope that early scientists coming along, or starting, even amateur scientists, I don't mean that in a negative sense, realize that there is value to being careful and not running to the internet the moment you think you have something. And that science, while it's not sacred in its rules, it's a process by which so much accomplishment has been done by humanity that it is worth making sure when we're coming to a problem like UAP that we apply the same stricture to it. And I know I'm speaking to the converted in many ways, but there's a lot of people who don't appreciate that yet and are constantly asking me on various threads or in venues, why haven't you done this? Why haven't you done that? Well, maybe I am doing it, but I'm just not ready to tell you yet. And so, follow the leaders in how they're doing it. And because we've lived in worlds where that's the norm. And, we hope that the next cadre of leaders is going to come forward, having seen that we actually didn't get blown out of the water the moment we stuck our toe in it.
Yeah, I must say, I always had a problem with that. Some people think that there are questions like the UFO questions that basically can't be tested, that they believe that no, this is so much, it's so complicated, and they form almost ideas or that cannot be tested through hypothesis. And I'm thinking that if there is such an effect, such a big effect that so many people see, that you have mass sightings, this should be testable. And I believe in the scientific method. You form the hypothesis, you put forward your test, and you go and carry it out, and then you analyze the data and see what's the outcome. There's of course going to be a lot of trial and error, and you might have to refine the hypothesis, you might try to try another one, but still I think everything can be tested. And I just don't submit to the idea of that the UFO question is so complicated that you can't try to test it out with science.
So I have a question for you, Beatrice. Can these experiments be done today, given all the...
Oh my God, yes, that's the trouble. That's a serious trouble, how to do it today. And I wrote another paper about how we can do it today, where we apply the Earth's shadow to filter away all the satellites and all the space debris. Because
but do we have to blow up a nuclear bomb to do it?
Well, I would prefer not to have to do that.
Yeah.
And I'm wondering, like, how can we check it? Maybe we need to search for these objects at 80,000 kilometers height.
Mm-hmm.
Maybe we need to go at big altitudes. Maybe Avi and the Galileo project can all give us ideas of how to do this much further out.
How about regional conflicts that are sub-nuclear? Because there's so much in the literary history of stuff showing up over the battlefields of Alexander the Great or Chinese warlords, etc. Are some other transients waiting to be correlated to troop movements?
Well, there is this group from Ukraine, from Kiev Observatory, and they had seen UAPs of two different sorts. I forgot what they call them. I forgot the names.
I remember
close to the war zone, and of course we were wondering, are they watching some secret weapons, or are they watching actual UAPs? It's super difficult because, again, it's the same trouble very often when you do science, you have degeneracy between two different interpretations, and you need to try to find a way of knowing which is it that is the most important.
There's a great documentary that I won't go into great length on called Chimp Empire, where anthropologists had settled themselves amongst these chimpanzees in a forest for 40 years, so that they essentially became invisible. But they were able then to watch the conflicts and film the conflicts amongst the chimpanzees in real time, because the chimpanzees just ignored them. So maybe we're the chimpanzees, and we've been so attuned to the ignoring these things in our environment that we don't see them when they're actually there to watch what they consider to be an interesting human event. Now, I'm speculating, but Daily Mail will say tomorrow something different.
So I've got a question for both of you, and I want to ask this because it says something about something very unique I think you guys are both doing. In order to approach scientifically the possibility or the reality of the UAP presence, you both are drawing correlations or looking for correlations between historical events and data left behind in historical events involving potential UAP, and then data that you can really gather in the normal fashion using scientific method and the instruments you need for your science. So Beatriz, you're doing this by drawing correlations between historical mass UFO events or events taking place with nuclear weapons or in conjunction with nuclear weapons, and then astronomical data. Garry's doing it with historical UAP sightings where materials are allegedly left behind, and yet he's examining the materials in a way that would be extremely normal within science. So, maybe both of you could comment on that, because I think that's very unusual for scientists to do this outside of kind of forensic studies.
Well, I can start with, I'll start with one and then you think of yours, Bea. So, for instance, I've been looking at the Ubatuba sample, and the results that I have with Jacques are radically different than those of Robert Powell. And he actually contacted me a couple of weeks ago to let me know. I said, well, wait a second, Garry, I think you're wrong. I know X. And so we've been corresponding back and forth about the difference between my results and his. And the short answer is we're both right, and that we might have actually each received different samples. And so we're actually talking right now about seeing whether or not well, we're going to try to compare and see what it is and what the chains of custody are for the samples, and see whether or not there's at the very least a paper to put out there on them. But there's no way X and Y can be true at the same time. But it's a positive interaction where we're looking for the truth of the matter, and neither of our egos are involved in the outcome, except we want the truth. We want to find the truth before the internet trolls do.
That sounds good.
Yeah, no, it's good and it's fun.
Yes.
So Beatriz, maybe you could say a word about this, because to me, Beatriz, one of the things that struck me about your work when I first encountered you was and I've already said it in this interview, but it was very ingenious of you to look back at these old astronomical plates. It was a simple decision, but you were able to say, look, pre-Sputnik, there shouldn't be anything there.
Well, this was a chance thing, because I was looking for vanishing stars, and then one, of course, discovers that there are multiple uses of these pre-Sputnik plates. So it wasn't. It came from another work as initially, but then let me think where it was leading. I'm also thinking a little bit about this other projects I have, like hobby projects, where we are like looking at the Baltic Sea anomaly, and we also have another case of a possible crashed UFO. And then we also would like to collect samples, of course, to learn what it is, what are these materials, and to get them analyzed to know if there's something special about these objects or if they are very mundane things. Because there's one thing to watch things on images. Like astronomers, we watch things on the images and we try to interpret them, but we don't touch the objects. And another thing to actually go there, like Garry gets the samples, the material, and does a material analysis. And we also would like to have that opportunity with our projects. So I think that's the real goal. Not only to think about is like not only to model or interpret observational signatures, but to actually get a part of such an object and have it in your hand to analyze.
So, go ahead, Garry.
No, it's okay.
Well, I was going to say, this is where the two of you in your research very much intersect, because you're both interested in materials for this reason. And that brings us to what's often the omnipresent question with UAP, which is how does secrecy end up intersecting with scientific research? And both of you, I think, have encountered the fact that the U.S. government has had longstanding interest in UAP and does treat UAP as an intelligence matter. Garry had a surprise visit from intelligence community scientists many years ago who wanted to speak with him about UAP related research. And Beatriz, I think you've had your own encounters with people from the intelligence community that have shown a little too much interest in your research. So perhaps both of you could say a word about that.
Well, I mean, my story is well recounted. It was the introduction of me to the medical issues around, well, ended up being mostly Havana syndrome, but a host of similar cases. But I think, again, the positive outcome of all of this has been, I've worked directly and positively now with people from the Senate Intelligence Committees, the House Intelligence Committee. This is even pre-Sol, and the FBI, who have all come forward in a most positive sense, seeking help and advice. So to the extent that there are, shadow elements trying to stop stuff, the positive aspects of both government and, let's call it, police investigatory elements of the government are now stepping forward to, at the very least, ask our help, and have in several cases, even military people have offered me personal security if I ever need it, because they recognize the value of people stepping forward like this. So yeah, there's negative, but there's also a fair amount of positive.
Well, I don't know how much I can say about this but to start with, I only work with very transparent data, and I only work with things that you can download from online, like these Palomar plates that are publicly available. I don't have access to any sort of secret stuff. And everything that, like, for example, the stuff we do work with the Baltic Sea anomaly is going to be public when published. But yes, there is an interest, and I have been approached by curious people that want to know a lot about the science I'm working with, including this, the crash retrieval stuff. And I don't have so much to, like, I don't have information that they cannot get in public, because I don't have any security clearance. I will probably never have it because I'm not good at keeping secrets, and I have never signed an NDA. So if someone sends me someone of these guys or girls, or if someone, when they have been coming to ask me questions, everything I do is public. Everything I do can be found in my interviews or at the universities, like official documentation, or in my papers, especially in my papers, because a lot of people ask me questions that are actually in the papers, but that they don't read. So there's no, like, big secrets. Well, the crash retrieval projects are still, like, not having any public information about them, but yeah. There is interest.
But a necessary condition of doing research that would be that sensitive and that could be that breakthrough. I want to ask you both a question, and you guys should ask each other questions about this too, or follow up with each other. But I want to know, I mean, what do you say to colleagues in academia and the sciences who find your pursuit of data pointing to the existence of UAP or UAP technologies to be puzzling, unjustified, even unscientific? What are you saying to those colleagues?
Give it time. I mean, there's stigma. There are going to be people who try to, like, discourage you from that. Just give them time. Everyone needs some time to accept the ideas, to think about these possibilities, and to see how this field becomes real slowly, step by step. I don't think one can push anyone to believe you or to think like you. Also, one just needs to let the natural steps happen.
Question back to them is, how much time do you have? And second, how much time have you spent actually looking at it, rather than parroting somebody else's conclusion? And what you very quickly find when challenging them that way, that they admit that they know almost nothing. And then I say, well, have you read the book, for instance, UAP or UFOs in Government by Robert Powell and Swords? Have you read anything in this field? Do you know what Project Blue Book is and was, and what the pros and cons of it are? And, you know, in basically 2 minutes, you can show just how ignorant they are of the matter. And then I follow up with, well, I've spent time and read all of those books cover to cover, as well as about 200 more. So it's kind of like you coming to me and telling me cancer is not real. And then I basically take you into a pathology lab and show you thousands and thousands of preserved blocks of human tissue representing cancer. And that pretty much, in very short order, shows who's doing science and who's not. So we all need, for those of us who are in positions like B and I, to have at the ready those kinds of immediate challenges back, because they can always ask a question that you can't answer, or you'll say, well, where's the evidence? Well, there's lots of evidence. Evidence is contextualized data. There's enormous amounts of data. It's just whether or not it meets the reproducibility test. So for me, reproducibility is materials or medical damage. For B, reproducibility is, do I see the same thing on a photographic plate on day 1 versus day 2 and or from multiple observatories?
Yeah.
And so that's reproducible science that, again, once you've stepped into that realm, there is no argument to be had. The data is indisputable. What it means is interpretable. And as long as you stay on the comfortable side of that line for the audience, you can keep them with you. I mean, I might have my own personal beliefs that's on the other side of that line, but my personal beliefs are different than my scientific conclusions. And getting that across to people often takes a bit of a longer conversation, but you can have that first conversation where you basically get people to admit that they know nothing about the matter that they're attempting to opine upon. And therefore, they might as well just go to a Facebook forum and spew their guts there and their opinions, because it would have as much value. Sorry,
Beatriz, any further thoughts about that?
Well, I agree with Garry. It's like my scientific conclusion from this work we've been doing now is that we see something that shouldn't be there in these images from the early 1950s, something that happens to look like something very flat and very reflective and in high orbits, probably. And that's my scientific point of view. And if you ask me about my personal, I'm going to say I think it's artificial and it's not ours.
Right.
So,
I mean, look at what Avi is going through right now with the more recent meteor coming through our solar system, where it appears to have an internal light source. And there's lots of natural reasons why it could have that, which he goes through. But because one or two lines of his opinion say that, well, it could be a nuclear reactor or an artificial energy source, that's all anybody focuses on. And so therefore dismisses all of the other more prosaic answers that he's even very comfortable with. And so, I think sometimes holding back the speculation of what it might be, even if the question is on the table and you believe that it's true, is better to get it into the public realm first as an accepted paper and then speculate after it's been published.
That's true. That's true. I'm very bad with holding back anything, I think. So, but yes, it's true. It could be easier sometimes because people want to poke holes on arguments. They don't want to read what you say. They don't want to read what you write. They will not read when you listen a mundane explanation. They will go and try to attack the more interesting explanation. So,
yeah.
You guys have both shown, I think, immense courage in engaging in dialogue and debate with your colleagues and doing research really at the edge or beyond the edge. And you've also both shown, and I really believe this is true, remarkable imagination in how you've approached the questions that interest you. So it may not seem this way even to yourselves, but I think there are younger generations of people going into the sciences and starting out in science right now, who are probably looking to both of you as possible models or even inspirations for their work. So what would you say to them? I'm really asking, for like, this is a fundamental question. What would you say to both of them that science is? Or what would both of you say science is? What Beatriz, is science?
For me, it's data-driven exploration. That's what science is to me. But of course, if you're a theoretician, you think differently. So, but this is at least my personal point of view of it. It's you just want to explore and the unknown the unknown domains that you can't get answers to in any books. When the books don't give you the answers, then you have to go and check it yourself somehow. So
yeah, I think where hard science and theorists overlap is that the hard scientist will collect the data often with a preset understanding of what they think the answer might be. And the theorist is there to either explain the data as it's collected or explain the outlier. And where, astrophysics, and where I think, for instance, Avi has a lot of problems with astrophysicists is they come up with magical theorems that are inherently untestable. And so, in retrospect, looking at my path or through science, it's always been either the unmet need that drives for me the creation of an instrument that lets me collect more data until I get to the point where the data doesn't make sense. And then it's that data off the curve which then redirects my interest. And I think this is where B is at right now. This data off the curve is redirecting her interests into understanding what it might mean.
Yeah, that's how my whole career path has been, that you find these weird things you don't understand and you try to form a hypothesis, how to test it, and it just goes on like that.
So you're actually a theorist, B. I know that's a dirty word amongst material scientists, but
I know I am sitting at the Nordic Institute for Theoretical Physics.
Oh, okay. All right. Okay, good. All right.
Okay, so as we kind of wind down, I want to ask both of you. I mean, where do both of you hope that the public UAP conversation goes in the next years? And what do you want to see happen both with governments with respect to UAP, but also what do you want to see science do with UAP?
I would like to see that governments actually support UAP science and that they really help at every, in every country there should be at least a couple or 5 or 10 scientists that work with trying to understand what are UAPs and if they are important for national security questions, and this needs to be civilian scientists. So I hope this will happen. I also hope that there will be some transparency from every government regarding the UAP question, so that we don't have to reinvent the wheel. Because to me, it feels like when we set up our projects to search for UAPs in the today skies, it feels like we are reinventing the wheel. The military do these things much better than us. They have had much more funding. They are 30 years ahead. So I think we need transparency and a little bit of help to be able to catch up, even if we might not be able to catch up. But
yeah, I think kind of back to the casino model, we're placing bets. And there was a huge fight back in the 90s, in biology at least, between what was considered basic science versus translational science. And it was actually Paul Berg, I think, who was a Nobel Prize winner at Stanford in the biochemistry department, who coined the term from bench to bedside, which bridged that gap between the basic researchers who just thought that basic data collection was important, as opposed to the translational researchers who felt like, hey, we needed to pay back the citizenry for the taxes they paid that gave us the money to do our academic elite biology science in the form of drugs or therapies or diagnostics that would help. And so, that transition happened in the 90s, the bench to bedside. But plenty of bets had been placed on the table already for what would be opportune directions in science to go. And I think that we're at a stage in UAP research where there's enough clear evidence, which is not proof, evidence that there's something interesting here. And it's really then up to the younger generation to pick up that mantle and run with it. Because there's stuff that even I know of, but I don't have the time to go after, that I know could create a new career in material science for people alone, just material science alone. Place those bets on the roulette table. That's where we're at.
Okay, great answers from both of you, and thank you to both of you for joining. Garry, thanks for offering your insights and asking so many great questions of Beatriz. And Beatriz, thank you on behalf of everybody involved in the conversation about UAP for doing such ingenious research and for sharing your thoughts about it. So,
and congratulations for making such a splash. It's fantastic.
Thanks. We will try to make all this data available for everyone so that also more people can have fun with it and discover the flying saucers. Yeah. I don't want to be the only one with an ontological shock. So,
right.
Okay. Well said. Thank you both.
Thanks.
Bye-bye.
Okay, so thank you for joining the Sol Forum. Again, it's the Sol Foundation's monthly digital meeting devoted to the science, philosophy, politics, and culture of UAP. Consider joining the Sol Foundation as a member. That gives you access, early access to broadcasts of these meetings, as well as to Zoom breakout rooms that take place after them. And keep in mind that both Garry and Beatriz will be speaking at our annual symposium, which takes place in Baveno, Italy, north of Milan, in late October of 2025. Registration is open, so go ahead and register if you're interested. If you're hearing this in August, September, or October of 2025, it's a unique event. People who are into the subject, from academia, government, the private sector, technology, really all professional fields, or who are just enthusiastic about the subject, love the meeting. It's a great place to engage people like Garry and Beatriz in person and to hear them speak in person. And it's also a one-of-a-kind of opportunity to network with people who are interested in the field and who are serious about it. So please consider registering and membership with the Sol Foundation. Thanks for listening.